Hi class, welcome to chapter 12, and we're going to study study vectors in the geometry of space. In this lecture here, we're going to start with an introduction in section 12.1 talking about the three-dimensional coordinate system. So in much of your math courses before, we've worked in the two-dimensional system or just the XY plane. Here we're going to expand this into the three-dimensional world that we all live in and put some mathematics behind it. Okay, so first topic today is going to be 3D space. So to locate a point in a plane, two numbers are necessary. We know that any point in the plane can be represented by an ordered pair, this a, b of real numbers. So think of the a as the x coordinate and b as the y coordinate. So, you're used to seeing ordered pairs as like 2, 5, 2, 3, things like that. For this reason, a plane is called two-dimensional. So to locate a point in space, however, three numbers are required. So we represent any point in space by an ordered triple. So no longer an ordered pair, but an ordered tripled, A, B, and we're adding in a new real number, C, here to our ordered triple. Okay, in order to represent points in space, we first choose a fixed point O. This is going to be called the origin here. Okay, and three directed lines through O that are perpendicular to each other called the coordinate axis. So we have the x-axis, the y-axis, what you're used to, and now a new axis called the z-axis. Okay, so we usually think of the x and y-axis as being horizontal and the z-axis as being vertical, as you can see in this figure here. So horizontal and then the vertical. Okay, so the direction of the z-axis is determined really what's called by this right hand rule, as you can see illustrated here in this figure. So if you curl your fingers of your right hand around the z-axis, so as you're listening and watching this video, just curl your fingers around like you see in the picture here. The z-axis in the direction of the 90-degree counterclockwise rotation from the positive x-axis to the positive y-axis. Then your thumb points in the positive direction of the z-axis. So think of it as, I know it seems weird, but a thumbs up for where the z-axis is located. The three coordinate axes determine it three coordinate planes, okay, that you can see here. We have the xz plane, the yz plane, and the xy plane. Okay, this xy plane is where we've been spending most of Calc 1, Calc 2. So now what we're doing is we're creating these two other planes to bring us into a three-dimensional space. Okay, so these three coordinate planes, the xy plane, the xz plane, and the yz plane, divide space into 8 parts, or called octants. Okay, so the first octant right here is in the foreground of this picture. It's this little box square here. And this is where you have the positive of all axes. So the positive of the x-axis, the positive of the y, and the positive of the z. All right, so because many people, myself included, have some difficulty visualizing diagrams of three-dimensional figures, you may find it helpful to do the following, looking at this picture here. So look at the bottom corner of a room and call that the origin. So like I'm in my office right now, and in the left-hand corner down from me is where the floor and two walls meet. That's going to be my origin. So the wall on the left here, okay, is the xz plane. The wall on the right here is the yz plane, and think of the floor as the xy plane. Okay, so the x-axis runs along the intersection of the floor and the left wall. The y-axis runs along the intersection of the floor and the right wall. So this is the y-axis, the x-axis, and that z-axis runs up the floor towards the ceiling where everything intersects. So this right here, this corner, think of that as your z-axis. All right, so you also, as you're watching this video, are situated in the first octant, and you can now imagine 7 other rooms situated in the other 7 octants, 3 on the same floor and 4 the 4 below. All right, and they're all connected by that corner common point, the origin. All right, now if P is any point in space, let's let A be the directed distance from the YZ plane to P. Let's let B be the distance from the XZ plane to P. And let's let C be the distance from the XY plane to P. Okay, so we can represent the point P as the ordered pair A, B, C of real numbers, and we call these A, B, C the coordinates of P. Think of A as the X coordinate, B as the Y coordinate, and really what we're doing is we're introducing this C now as the Z coordinate. Okay, so thus, to locate this point ABC, you start at the origin. You move A units in the x-axis, B units in the y-axis, and C units in the z-axis. Okay, always. So like if it was negative, you'd be going backwards this way. If it was negative z, you'd be going down. But x, y, and then z. Okay, so the point ABC determines, you can also think about it as a rectangular box that you see here. So if we drop a perpendicular from P to the XY plane and get point Q with coordinates A, B, 0, this is called the projection of P onto the XY plane. So if you take your point and whoop, just look down here, this is the projection onto the XY plane. You can do the same. Point R is the projection onto the ZY plane or YZ plane, and S is the projection onto the XZ plane, and so on. And you can see that the point here can form this nice little rectangular box. All right, so let's, as a numerical illustration, what I've done here is I plotted the points. First, -4, 3, -5, and then 3, -2, -6 are plotted in the figures. So to get this point here, I started at the origin. I went backwards 4 units along the x-axis negatives, 3 units y, and then -5 units down to z. And you can do the same thing here. X is +3, over to -2, and then down to -6. And that's exactly how you plot them. Okay, so the Cartesian product, the r times the r times the r, the real number system times the real number system times the real number system, gives this ordered triplet. X, Y, Z is the set of all ordered triples of real numbers and is denoted by r cubed. This tells us that we're in three-dimensional space. So we have given one-to-one correspondence between points P in space and the ordered triplet RBC and the r cubed. Right? It is called a three-dimensional rectangular coordinate system. Notice that in terms of coordinates, the first octant can be described as the set of points whose coordinates are all positive. Okay, and then the other octants, have at least one negative value. All right, class, hope that helped as a quick introduction.